In this video, I will show you how to factor a trinomial using the box method and the grouping method, and you'll see that they are very, very similar. First, let's do the box method. Step one is to look to see if there is a common factor, and in that case we would take out a GCF, but there are no common factors, so we'll just move on. So the box method relies on a product and a sum. So we need to find the product and the sum right away. The product comes from A times C. This is A, this is C. So that will be positive 10. And again, that came from A times C. The sum comes from the B value, which in this case is 7. All right, let's start with the product. The product is 10. Let's make a list of all the ways we can multiply and get 10, starting with 1 times 10, and then we have 2 times 5, and that's the end of the list. Now let's look at the sum. We need to add one of these pairs in order to get positive 7. Which one will it be? Well, it's clear that 2 plus 5 is 7, so that's the pair that we're going to use. Please note that we can change the signs if we need to. This could be negative 2 and positive 5, or negative 2 and negative 5, etc. But for, whoops, I wrote down 7. But in order to get 7, we want a positive 2 and a positive 5. Whatever we choose, we have to use the exact same numbers for the product. Does 2 times 5 equal 10? Yes, it does. So we found the pair. So now it's time to draw the box, which gives the box method its name. Okay, in the first box, we put the first term. So 10x squared will go here. In the last box goes the last term, so I'll put 1 here. The other two boxes, we will use the two numbers that we just found. So we'll have a 2 and a 5, and these will both be x terms, always. Now we will take the GCF of each row and each column. The GCF of the top row is 5x. The bottom row has no common factor, so that means it is a GCF of 1. And we'll call it a positive 1 because the first term is positive. Okay, the greatest common factor of the first column is 2x. There is no common factor other than 1 for the second column, so I'll just put plus 1. So these purple numbers give me the two binomials that form the solution. So on the left I have 5x plus 1, and across the top I have 2x plus 1. So this is the factored form for the original trinomial. If I were to multiply these two binomials together and combine like terms, this is what I would end up with. Okay, so that is how you factor using the box method. Okay, now you're going to see just how similar the grouping method is. We've already established that there is no GCF, but if there was one, we would still do that for the grouping method. And you know how in the box method the first thing we do after the GCF is a product sum? Well, guess what? Grouping method is no different. We still start off with a product and a sum. Okay, so we will do the same thing as before, product and a sum. Okay, we would do the same process with the 1 times 10 and the 2 times 5. Oh yeah, I forgot to say, just like we always do, the product is A times C, so that's 10. The sum is the B value, so that's going to be 7. Okay, nothing has changed. Just like before, we picked the 2 and the 5, and 2 times 5 makes 10, so that was great. Okay, all of that is the same. Now, here's the part that's different. There will be no box, because this is not the box method. So instead of writing a box, you start by writing down the first term. That's going to be 10x squared. Okay? Now, the middle term, you're going to split apart using the two numbers that we just found. And again, these will be x terms, just like they were in the box method. So we will have 2x plus 5x. Okay, so notice I'm just replacing 7x with 2x and 5x. And then I will continue on and bring down the final term unchanged. So we just split apart the middle term as 2x and 5x. And again, we got that from this process right here. Okay, so now for the grouping method, what you do is you do the GCF of the first two terms, and you do the GCF of the second two terms. Okay, so the GCF of the first two terms is going to be 2x. So I will pull out a 2x, and then I will ask myself what goes inside. So remember, to figure out what goes inside, you divide by the GCF. So I'm dividing by 2x. Okay, so that is going to leave behind 5x plus 1. All right, so I just factored out the GCF from the first two terms. So now I'm going to do the same thing over here. However, there is no common factor other than 1. So I'm going to go ahead and show the 1 outside of parentheses. But factoring out a 1 doesn't change anything. I'm still going to have 5x plus 1. All right, I'm just showing it this way to show what will be left behind once I take away the parentheses. So what you need to understand is the parentheses themselves are a GCF. This factor, 5x minus 1, appears twice. This is itself a common factor. So just like we always will take a GCF and put it out front, we're going to do the same thing with the entire parentheses. Okay, so we're going to take 5x plus 1 and we're going to put it out front. Okay, so I'm going to have 5x plus 1 out front. Now, if I take away the 5x plus 1, what's left behind? Because that's what will be left inside the parentheses. Well, what's left inside is going to be the 2x and the plus 1. So guess what? This is going to be the final answer. Now let's just scroll over and compare. Okay, notice that we're getting the exact same answer that we got the last time, which makes perfect sense. Problem number 2. We're still doing the same thing. We're going to factor this problem right here in 2 ways. You know what? Maybe I'll just put problem number 2 somewhere. So this is problem number 2. All right, we're going to do this by the box method, and then we're going to turn around and do it by grouping. So is there a GCF? No, there's nothing common to this. So let's go straight to the other thing. Product, sum. The product is got to be A times C. That's 3 times 15, which is 45. So that's the product. The sum has to be the B value. That's negative 14. So let's start with the product. Let's start with that 45. You know what? I'm going to put this over here so we can use it for the grouping easily. So 45, that's going to be 1 times 45. 2 doesn't go into 45. 3 does. 3 times what? Oh, 3 times 15. That's where we got the 45 from in the first place. So 3 times 15. 4 doesn't go into 45. 5 does. Okay, that's 5 times 9 is 45. And that's it. These are the 3 ways to make 45. Now, which of these can give me negative 14 if I pick the signs right? I'm hoping you can see that 5 and 9 is the pair that can give me negative 14. If both of these are negative, if I have negative 5 and negative 9, negative 5 plus negative 9 is negative 14. So we have to use the same numbers for the product. And negative 5 times negative 9 is positive 45. So we did it. We're good. So now we can go ahead and set up the box. Okay, so the box is going to look like this. All right, in the first box goes the first term, so 3x squared. In the last box goes the last term, so 15. Okay, in the other 2 boxes, we will use the 2 numbers that we have. So we will use the negative 5 and the negative 9. These will both be x terms. Next, we do the GCF of every row and every column. So the GCF of the top row is going to be 3x. The GCF of the bottom row is going to be negative 5. The GCF of the first column is x. The GCF of the second column is negative 3. So that will give us 3x minus 5 times x minus 3. Of course, we're getting those binomials from the left and the top. Since there was no GCF that we pulled out in the beginning, then there's no number I need in the front, and this is the final answer for problem number 2. Well, box method. Okay, now let's jump over and do it by grouping. Of course, this is still problem number 2. We're just doing it by the grouping method now. So look, the first steps of the grouping method are the same thing. We still do product and sum. All right, the product is still A times C, 45. The sum is still the B value, which is negative 14. We make the list, just like we did before. We choose 5 and 9, just like we did before. Negative 5 and negative 9. Negative 5 times negative 9. All right, this part is exactly the same. All right, but now here's where it changes. Instead of drawing a box, we do something different. We're going to rewrite this trinomial. We will start by just bringing down the 3x squared. It's the second term where all the magic happens. Okay, so this middle term is going to be split up into 2 parts. And we're going to use the 2 numbers that we just found. So we're going to have negative 5x and negative 9x. Okay, so we're splitting negative 14x into negative 5x and negative 9x. All right, and then we will continue on and just bring down the plus 15. Okay, now what we do is we need to do the GCF of each pair of numbers. So we're going to do the GCF of this pair, and we're going to do the GCF of this pair. Okay, so the GCF of the first 2 terms is x. Okay, now to figure out what goes inside the parentheses, I divide by that GCF. So that's going to give me 3x minus 5. Okay, now the GCF for the second pair is going to be negative 3. And again, to figure out what goes inside the parentheses, I need to divide by the GCF. I need to divide by negative 3. So that's going to give me positive 3x minus 5. Notice how the parentheses are the same. 3x minus 5 and 3x minus 5. That means that 3x minus 5 is a common factor. It's a GCF. So just like we always take a GCF and put it out front, we're going to take 3x minus 5 and put it out front. 3x minus 5 goes in the front. Now, what would be left if I took away the parentheses, if I took away the 3x minus 5s? Can you see the purple part is what would be left? It would be x minus 3 would be left. So guess what? This is the answer right here. 3x minus 5 times x minus 3. All right, let's compare that to what we got the last time. Oh, look, it's exactly the same thing. 3x minus 5 times x minus 3. Of course, you get the same answer regardless of whether you do the box method or the grouping method. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.